Good morning, Professor. Today we will represent you guys about research on fabrication and characterization of ZnO-grafted C3N4 nanomaterial to remove ciprofloxacin in aqueous solutions. In the abstract, we conclude two main things. First is ciprofloxacin, CIP, is one of the antibiotics with the highest rate of antibiotic resistance. If we use and manage improperly, it will affect the ecosystem. Secondly, is C3N4 is an organic semiconductor with titanium oxide and zinc oxide. Create a new generation photocatalytic material. Down here we will have the research procedure with the synthesis, material characterization, and application. To know clearly about our presentation, we will continue with the material crystal structure.
The SEM image of the pristine GC3N4 structure was found to be identical to the project layer morphology of urea. Derived GC3N4 reported previously. The morphology of the composite can be observed as a loose structure with an increased surface area and porosity. After the addition of ZnO, the average size of GC3N4 and ZnO GC3N4 nanocomposite is 0.3 to 0.8 micrometer.
The research showed that there was a slight increase of photocatalysis degradation efficiency at CIP from 30% to 38% when increasing heating temperature from 450 Celsius degree to 550 Celsius degree. However, high synthesis temperature at 600 Celsius degree could destroy the morphology and structure of these C3N4, thus resulting in low degradation efficiency at about 15%.
Following up, we have the elemental composition table index. The element nitrogen accounted for the highest percentage by mass at 49%, while the remaining element carbon accounted for 41%, zinc 6%, and oxy 23%. Elemental mappings of nitrogen, carbon, zinc, and oxy showed in figure.
About the optimum ratio, it was indicated that the 5% of zinc oxide mass ratio gave the highest efficiency at 71.76%. Specifically, when the zinc oxide content increased from 3 to 5%, the efficiency of photocatalysis increased. Regeneration capacity of our material was reached at least first cycle and reached above 80%.
Lastly, we have a summary. Under visible light, zinc oxide GC3N4 composite show enhanced photocatalytic degradation efficiency with 87.36% of ciprofloxacin compared to pristine GC3N4. The reusability of material was studied via 3 cycles of photocatalytic tests for CIP degradation in the same condition. The zinc oxidized GC3N4 show excellent reusability up to 3rd cycles without any noticeable change in the degradation efficiency. That's the end of our presentation. Thank you for listening and for your attention.